Welcome to the DUCO Collaborative Robot Training course. Project Case. An electronic product manufacturer uses the DUCO GCR10-1300 cooperative robot with a vacuum suction cup fixture and a 2D visual camera to take the PCB board to be tested from the feeding table, send it to the testing equipment for testing, and put it into the matrix tray in the completion area after the testing is completed. Process description. Step 1. Manually place the PCB matrix tray on the loading table. Step 2. The GCR10 cooperative robot is equipped with 2D visual camera to take pictures, correct the grasping pose, and complete the material retrieval. Step 3. The GCR10 cooperative robot sends the PCB to be tested into the testing equipment. Step 4. After the inspection is completed, the GCR10 cooperative robot will place the PCB board after the inspection into the matrix tray in the completion area. Equipment composition. 1 loading table. Plastic matrix tray. 3 testing equipment. For a GCR10 cobot. 5 a 2D vision camera. 6 vacuum sucker fixture. 7 a completion zone. 8 a PLC. System network topology. Testing equipment, GCR10 collaborative robot controlled by PLC. Robot and PLC Profinet industrial bus communication. 2D vision camera and GCR10 collaborative robot TCP IP communication. Vacuum check fixture controlled by collaborative robot I/O interface. Internet protocol address assignment and signal interaction. Configure Internet protocol addresses and function signals and write programs. Create a new main program opening parenthesis main.jspf. Initializer opening parenthesis init.jspf. Loading table pickup program get_PCB.jspf. Testing program PCB_test. Finish the widget program put_PCB.jspf. TCP IP communication connection program socket_connects. Visual data receiving handler camera_date JSPF. Edit in the main program. The initializer is called first in the main program. Feedback initialization completion signal after initialization is completed. Then call the TCP IP communication connector. Determine the number of products on the matrix tray after the communication connection is successful. Enter the work cycle when the quantity meets the conditions. In the duty cycle, first wait for the matrix box pickup signal. After receiving the signal, call the loading station pickup program. Feedback the completion signal after the pickup is completed. Then wait for the detection device to allow the discharge signal. Invoke the detection program after receiving the signal. Complete the area release procedure. Feedback the completion area matrix tray discharge completion signal after completion. Finally, the number of remaining materials in the matrix tray is calculated. Bool output register signal reset. Edit in the init program. 4 script function blocks have been added to the init program. The first script function block judges the output signal of the configured home location function. Complete the inspection of whether the robot arm is in the home position. The second script function block resets all bool output registers in the signal table. The third script function block defines a function with parameters gripper, realize section, and blowing control of vacuum suction cup fixture. The fourth script function block controls the vacuum check fixture reset by calling the gripper function. Edit in socket_connect. Socket_connect added a script function block. Use socket_open script command to make the robot establish a TCP to IP connection with the camera. and ensure the connection status by judging the return value of the instruction. Edit in get_PCB. Get_PCB program. Camera pose is declared. Variables of type get_PCB and get_PCB_base pose. It is used to store the pose information of the camera bit, the compensated grab bit, and the basic grab bit. In the script function block, by judging the system variable G_PCB_count that records the number of PCB boards on the matrix tray, offset the camera point and the grabbing point. The completion zone matrix tray pickup path was taught using the moved joint movement command and the moveable straight line movement command. Edit in PCB_test. PCB_test program using moved joint movement command and moveable straight line movement command. Taught the detection equipment release and pickup path. Gripper function is added to realize the opening and closing of the vacuum suction cup at the pick-hand place point. After the detection equipment is placed, use the wait function block to wait for the detection completion signal. After receiving the detection completion signal, execute the extraction of the detection device track. Edit input_PCB. Put_PCB program using moved joint movement command and moveable straight line movement command. Taught the completion area matrix tray release path. In the script function block, by recording the number of PCB boards on the matrix tray. The judgment of the system variable G_PCB_count shifts the placement point. And add the gripper function under the placement point to realize the closure of the vacuum suction cup. The program is written and automated mode testing is performed.